How's it going again, ladies and gentlemen? Mr. Johnny here, looking at 12.2 redox reaction things. So what we want to be able to do, identify what is oxidized and what is reduced from a chemical equation. We also want to be able to identify the oxidizing and reducing agents as well as any spectator ions for these redox reactions. So first things first, what are redox reactions? Well, the term redox is actually broken up. It's from two different words. First one being oxidation. Notice how I bolded the ox part because that's the ox part, right? Well, what is oxidation? Oxidation is losing electrons, or losing electrons is oxidation. All right. Reduction, notice RED, redox. Reduction is gaining electrons. All right, so gaining electrons is reduction. Now, how are you going to remember these two? We've got a couple of different memory hooks you use, whichever one works best for you. Leo, the line says GER. So that would be losing electrons is oxidation and gaining electrons is reduction. Another way is oil rig. Oxidation is losing electrons, right? And reduction is gaining electrons. Either one will work. You pick whichever one is your favorite and stick with it. All right. So what's going to happen? How will we know what was oxidized and what was reduced? Well, things that are oxidized, the charge becomes more positive from left to right because it lost electrons. You got to remember that electrons are negatively charged. So if you start getting rid of them, you're going to make it more positive, right? And the opposite is true for reduction. If it's reduced, the charge is reduced. The charge becomes more negative, right? From left to right because it's gaining those negative electrons, it's going to become more negative. So first thing that we got to do here is, all right, here's a redox reaction. I got to figure out the charges. So copper by itself is 0, and CNO3 is NO3 on both sides, and it is -1, which tells me that the Ag has to be +1 over here. Tells me that the copper must be +2 because there's two -1s from the two nitrates, and then Ag being by itself is 0. That's the hard part. Hard part's over now, right? So, yep, there it is. Now we want to identify which one became more positive because that was oxidized, and which one became more negative because that was reduced. So if I take a look, Cu goes from 0 to +2. So if it goes from 0 to +2, what kind of change is that? That is going to be oxidation because it becomes more positive. Whereas copper goes from +2. Whereas silver, Ag, goes from +1 to 0. So what happens there? Well, if it went from +1 to 0, then it was reduced. So the thing that, where am I at? All right, my bad. So +1 to 0, well, that is reduction. All right. Yep, that's what I said. So what about that NO3? The NO3 didn't really do anything, so it's considered a spectator ion, right? Think about the word spectator. It means you're just watching. What's the NO3 doing? It's not reacting. It's just watching those things exchange electrons, and it's not doing anything itself. So we call it spectator ion. So let's practice identifying what is oxidized, what is reduced. You know, this would be a good place to pause it and try it on your own, and and then see how we did. Well, all right, pause and play. All right, so H2 by itself is going to be 0. O2 by itself is going to be 0. H, I look it up, it's got to be +1 because oxygen is -2. So now we go, all right, well, what was oxidized? What went up in charge? Well, if I looked at the hydrogen, it went from 0 to +1. So I would say the thing that was oxidized was the H2, with the charge of 0. Well, what was reduced? Well, oxygen went from 0 to -2, so it was reduced. So the thing that was reduced was O2 with a 0 charge. All right, next one. I look up the charge of NO3, and it's -1. NO3 on the other side is also -1, so I go, all right, well, Ag's got to be +1. Copper by itself has got to be 0. Copper here is with nitrate, and there's one nitrate, so I know that it's got to be +1 charge. And Ag by itself is 0. So what went up in charge? What was oxidized? Well, copper went from 0 to +1, so it was the copper 0 that was oxidized. What was reduced? Well, Ag went from positive 1 to 0, so it was reduced. So we put Ag plus 1 because it was plus 1 that got reduced. All right, Fe by itself, 0. Oxygen, again, by itself, 0. Oxygen in the compound has to be minus 2. All right, well, I got one oxygen with a minus 2. I got two irons, giving me a positive 2 to cancel it out. So I know that each ion has to be positive 1. All right, well, what was oxidized? Well, it went up in charge. Well, Fe started as Fe0 and it became positive 1 charge. So that was oxidized. The thing being reduced would be the other thing, the oxygen. It started off with a charge of 0 and then it became charge minus 2. So it must have gained 2 electrons. All right, so I'm going to introduce some new terminology, some vocab. If you're a fan of the Matrix, you guys know who these are. They are the agents, right? So we're going to talk about oxidizing agents and reducing agents. But basically, if you say blah, blah, blah agent, it's describing what it is causing. So for example, a drying agent, like a towel, causes drying. You know, what happens to the towel? It gets wet. It causes things to dry, but it does the opposite thing. You know, just like how an adhesive agent causes adhering, right? It causes things to stick together. So if we're talking about oxidizing agents, they cause oxidation to occur. They cause oxidation. You know, they cause something to lose electrons. How do they do that? It's because the oxidizing agent is taking electrons. So the oxidizing agent is the thing that is reduced, right? It causes oxidation because it is taking those electrons, so it is reduced. Right? The opposite is true for reducing agent. You know, it causes reduction. It causes something to gain electrons. How does it do that? Well, a reducing agent gets rid of electrons and gives them to the thing being reduced. So that means that the reducing agent is the thing that's oxidized. Right? So cause reduction by losing its electrons to another atom. So if we take a look, here's the example from earlier. Since Cu0 is oxidized, it is the reducing agent. It causes Ag plus 1 to be reduced because Cu0 gives an electron to Ag plus 1. You can think of it like this, right? So we got Cu has got electrons and it's giving them to the Ag plus 1. Now Ag plus 1 is reduced, so it is the oxidizing agent. Think of it this way. Silver caused copper to be oxidized by taking its electron. So it took its electron, it caused oxidation. So it's the oxidizing agent, but itself, it is being reduced. All right, and the spectator ion is just watching, right? It doesn't change from beginning to end. It's just a spectator, just watching. Right, so that would be the NO3 in this reaction, right? We got NO3 on the left like this, and we got NO3 on the right like that too. Doesn't really change, doesn't do anything. All right, special note. When it's asked, you know, what is oxidized or what is reduced or what is the oxidizing agent or the reducing agent, you always give something from the reactants. All right, so you always got to give it from the reactants, including the charge. All right, so for example, the thing that's being oxidized is Cu0. You can't just say copper because which copper? Well, it's Cu0. That is the thing being oxidized. Cu plus 2 is already oxidized. It's not the thing being oxidized. Cu0 is. The thing being reduced would be the Ag plus 1. You got to give the element and its charge. So it'll always be something from the reactant side. All right, here's another example. All right, well, what's being oxidized? What's being reduced? What's the oxidizing agent? What's the reducing agent? Oops. Be a good place to pause it. Ready? Press pause. Now press play. All right, so we got to first figure out the charges. Zn by itself is 0. H2 by itself is 0. Cl, since it's the last thing, it's going to be its first charge. It's minus 1, which means H is plus 1. Now over here I have two chloride ions, each minus 1. So that means zinc must be plus 2. So, well, what was oxidized? What went up in charge? Well, it was Zn. Zn, well, which Zn? Which thing was actually oxidized? Zn0. I take from the reactant side, Zn0. Thing being reduced, well, it looks like the hydrogen was reduced from positive 1 to 0. So I got to give the charge, H with positive 1. Now, oxidizing agent. What caused oxidation? It was a thing that got reduced. So the oxidizing agent was H plus. Reducing agent would be the Zn0. All right, here's another example. Li by itself is 0. Zn by itself is 0. Zn here has to be plus 2. The nitrate ion's minus 1. Here, lithium's got to be plus 1, and the nitrate's got to be minus 1. So what is reduced, or I'm sorry, what is oxidized? What goes up in charge? Well, it's the Li0. What is reduced? The Zn plus 2. It went from plus 2 to 0. So what's the oxidizing agent? Well, it's the thing that got reduced. What's the reducing agent? It's the thing that got oxidized. And what's the spectator ion? For this one, it was NO3 minus 1. Do not forget the charge. It is an ion. You got to give its charge. All right. Yep. And do another example. All right, so K by itself is 0. Cl2 by itself is just chlorine, 0. Chlorine, last thing listed, is its first charge. It's minus 1. Potassium is going to be positive 1. So what's oxidized? Well, the K0 went up in charge, so it is oxidized. Reduced. What was reduced in charge? The Cl2 0. That was reduced to minus 1. So the oxidizing agent, the thing that got reduced, is Cl2 0. Reducing agent is the thing that got oxidized. Spectator ion here, there is none. No spectator ion here. Same thing but different. All right, well, I know oxygen has to be minus 2 from the periodic table. Na's got to be positive 1 from the periodic table. Here by themselves is 0. So what was oxidized? What went up in charge? This one's a little tricky, and it is actually the O minus 2 because it went from negative 2 to 0. So that is an increase in positive charge. It became more positive. What is reduced? Again, and kind of a little bit tricky, the Na plus 1. It went from plus 1 to 0. So that's the thing reduced. So if it was reduced, it is the oxidizing agent. Oxygen, being the thing that's oxidized, is the reducing agent. And spectator ion, there is none. That's it. Bring questions. See you in class.